Hello, my name is Mike Van Arsik, and I'm a professional system architect and modeler. I teach at the University of Detroit Mercy as an adjunct professor, and I have more than 25 years of engineering experience in both automotive and defense. I hold numerous certifications, including the INCOSE Expert Systems Engineering Professional Certification with Acquisition Extension, as well as the OMG Certified System Modeling Professional Model Builder Advanced. Why have I created this video series? Well, first of all, I believe that elegant designs are achievable, but that systems are becoming too complex to effectively develop them with traditional systems engineering, and I've coined a term DICE, Document-Intensive Systems Engineering, to use when referring to traditional document-based approaches. I firmly believe that model-based systems engineering is the best available solution for us to manage the complexity of modern systems, and that most texts on modeling are not adequate to help beginning modelers succeed and experienced modelers thrive. That demonstrations are the best way to show modeling principles. The best way to do this is to do it and to learn by seeing someone else practice it effectively. I create videos to teach my students, and I'm releasing this set as a courtesy of the systems engineering and modeling community. I need your help to stamp out bad modeling. There's a lot of inferior modeling happening, and it's hampering the growth of this critical discipline. I think there's three primary reasons for this. First of all, there still is this pervasive document-centric mindset. People can't break free of it and don't see a system description in terms of anything other than shall statements and text. There's a lot of unskilled practitioners out there who haven't been trained or are poorly trained or are using poor methods, and they go around making a lot of eloquent gibberish, as Matt House from PTC would put it. It's a lot of bad modeling that looks fairly impressive but doesn't really help improve the outcomes for a system. And there's a lot of inferior modeling tools out there that just aren't capable and don't enable system modelers to reap the full benefits of the modeling effort. And frankly, most stakeholders are not sufficiently sophisticated to really demand state-of-the-art system models from their modelers. So this video series is intended to address all of these. I will make several promises to you up front. I will be honest with you in my opinions. I have a lot of them. I've earned them through a lot of study and effort, so they're not ill-founded, but I will share them and I'll do my best to separate opinion from fact. I will point out alternative approaches if appropriate, if I think there's more than one way that are equally valid to tackle a problem. And I will do my best to explain why I use certain approaches or use certain modeling elements and relationships. My overall goal with this is to help advance the practice of systems engineering by increasing the supply of competent system modelers. So some warnings up front. Number one, I'm definitely not a tool agnostic. I'm a tool antagonist. I do promote No Magic's tool suite, both Magic Draw and Cameo System Modeler, because I believe they're far and away the most capable tools available, and I will not apologize for having that opinion. A lot of the method that we have here is built on squeezing value from these off-the-shelf tools. So a lot of what I will show you is pretty easy to do with the No Magic tool set. It may take additional work or be impossible with other tools. So again, you can try to adapt this to other modeling tools, and you may be very successful with some of this approach, but it's not my mission here to show you how to execute this with other modeling tools. I leave that as an exercise for you if that's your interest. And I will do my best to ensure consistency with this. I'm modeling a unified example cradle to grave. Will do my best to be consistent, but I may be forced to do some modeling and rework done off camera as I make adjustments if necessary. So again, I'm doing my best to make sure this entire set of videos is consistent, but you may see a few things jump or change. So these books all have something in common, and there's quite a few of them. This is the vast majority of the systems architecture and engineering texts released in the past 15 years or so. They also have something in common with all of these books as well. So the thing that all of these have in common is that I've read all of them, and many more books, and many published papers. And so as a result, I've been steeped in a lot of architectural and engineering thought my entire career. So I will do my very best to give proper attribution to original content authors. That may not be possible just due to the scope and magnitude of the content. So I'm not intentionally trying to steal someone else's thoughts and take credit for it, and I will do my best not to do that. I would also like to thank the following individuals who are both my co-workers, colleagues, and friends with whom I've had many discussions over the years at INCOSE events, NDIA, the No Magic World Symposium, my day-to-day job. Each of them has helped me evolve the concept of hypermodeling, and I apologize in advance for any omissions. There's the team at No Magic. There are my colleagues with INCOSE, and there are other individuals I've engaged both on the job as well as at conferences and in my teaching roles. So thanks to everyone here for helping to contribute to hypermodeling in some way, whether it was through showing me the answer to a question I was asking or just having a lively debate with me on systems engineering and architecture topics. Thanks to each and every one of you for your contributions. And a special thanks to the individuals here, Bill Schindel for his work on small of a system and some good pattern work, David Long for his contributions to systems engineering, and Sandy Friedenthal for all of his work with SysML, and Delaney Delegati for his work in teaching it and making it accessible. Thanks to each and every one of you for what you've done. Finally, I'd like to dedicate this to my wife and my kids for all that they've done to support me in my efforts. But most of all, I dedicate the entire hypermodeling effort to the unknown genius who helped craft and conceive of the Antikythera mechanism. For those of you who don't know what it is, I encourage you to seek out Nova's program on an ancient computer. But the amount of technology and thought that went into crafting this device thousands of years ago inspires me and pushes me to seek the limits of what's capable with modern equipment and tools.